Now we shall discuss about derivative of homogeneous functions. We had learned the homogeneous equation ax square plus 2hxy plus by square equal to 0. We learned it in the pair of lines, equation of pair of lines. This is a homogeneous equation of second degree. Degree of x square 2, degree of xy 2, degree of y square 2, and right hand side is 0. Such a function or such an equation is called homogeneous equation, and we need to find the derivative of such a function. I'll be teaching two methods to do this and two different answers which can be made to same answer, and then we will generalize an idea of all homogeneous functions, whatever the degree may be, what would be their answers. Okay, first let me differentiate with respect to x. When I differentiate this with respect to x, I will do it in few steps. A into derivative of x square plus 2h into derivative of xy plus b into derivative of y square equal to 0. So let me reduce the steps. A into 2x plus 2h into x divided by dx plus y, product rule is applied, plus b into 2y divided by dx equal to 0. We can see that all the terms are multiple of, every term has got a 2 in it. So I have divided throughout by 2 so that my calculation will be faster. And then coefficient of dy by dx, how many dy by dx terms? There are 2 dy by dx terms. What are their coefficients? One is hx, another is by into dy by dx. Term without dy by dx, terms without dy by dx, ax, hy with a negative sign, ax plus hy. So your conclusion, dy by dx is equal to minus ax plus hy divided by hx plus by. This will be the derivative of dy by dx. Now, we are going to show that this is nothing but y by x. I am going to take the second part of it. I want to prove that in this I need to prove that dy by dx is nothing but y upon x. So to prove that, what I should do is I go back to my equation. I take ax square 2hxy, I'll split it as hxy plus hxy, and then I take by square equal to 0. If you take x common, ax plus hy, and if you take y common, hx plus by equal to 0. So I can write x into ax plus hy is minus y into hx plus by. And you can see that ax plus hy over here. So ax plus hy divided by hx plus by is minus y by x. So I can replace this whole thing by y by x. How? So dy by dx will become minus of minus y by x. So dy by dx is y by x. This is what we can find. So whenever I differentiate any homogeneous equation, whether second degree, third degree, whatever it is, the derivative will be always y by x. Now I will show you another method to do this problem. When you are doing this, the board examination pattern I have showed you. Now with my logic, I will show you another way of doing this derivative in a homogeneous function. It is very simple method compared to what we did just now. So many steps are not involved. First of all, I start this equation and divide by x square. Divide by x square. This is a degree 2, so divided by x square. If a degree 3, divided by x cube. If degree 4, divided by x cube. Whatever the degree of homogeneous equation, first divide by that. So it will become a plus 2h, then you divide this by x square, y by x, and b into y by x the whole square equal to 0. Now, this has become a function in y by x. So let me differentiate now. Differentiating with respect to x, as usual. So d by dx of a, which is a constant, 2h into d by dx of y by x, plus b into d by dx of y by x the whole square. Do not take it as y square upon x square, take it like this. Derivative of 0 is 0, so right hand side is 0. This became 0. 2h into derivative of y by x, I am going to keep it as it is. But here, derivative of u square, 2u into derivative of u. Now, the common term here is 2h plus 2b y by x inside the bracket into derivative of y by x equal to 0. Now this is a function, x and y have different values. There will be some value for x and y, there will be non-zero. So we can divide it. So when I divide this by this, I'll get dy by dx of y by x equal to 0 divided by 2x plus 2by by x. 0 divided by anything is 0. So I get my idea, dy by dx of y by x is 0. Now this is what I want to tell you. Whenever you have a homogeneous function, if you do like this process, you will end up, this is a function in y by x. What do you mean by function in y by x? Whatever the variables that you have in this is y by x. Therefore, this is a function in y by x. When you differentiate an equation in y by x, can be easily obtained by differentiating that it is a function in y by x, so differential of y by x will be 0. Because you can see, you will get a common term like this. All others will go to the denominator of 0. Now if I differentiate this y by x, what will I get? If I differentiate y by x, what will I get? Let me start that. d by dx of y by x equal to 0. Product division rule, quotient rule. X into derivative of y minus y upon x square equal to 0. U by v method. Now cross multiply. You will notice that x dy by dx minus y equal to 0. So dy by dx will be y by x. It's very surprising. What is the surprise? When you differentiate y by x equal to 0, you will get derivative as y by x. This only happens in this, not everywhere. Whenever the derivative of y by x is equal to 0, the dy by dx also will be y by x. So we can apply this. So every homogeneous function is a function of y by x. So this is my second method. So let me make it like this. If I divide this equation by x square, a plus 2x y by x plus b into y by x the whole square equal to 0. That means this is a function of y by x. So I can say a function in y by x. When I differentiate a function in y by x, I will get this way. Now this function cannot be 0, so it will go to denominator of 0. So d by dx of y by x equals 0. And when you differentiate this, you will get dy by dx and then you get answer. Another example I want to show you in this. Imagine I have a function like this. Sine inverse of x square minus y square upon x square plus y square equal to some a square, a. Find or show that dy by dx is y by x. Now if you take the sine to the other side, x square minus y square upon x square plus y square is sine a. If you cross multiply, x square minus y square equal to sine a into x square plus y square. What have you noticed? Every term's degree is 2. This is a homogeneous function. So derivative of a homogeneous function will give you dy by dx equal to y by x equal to 0 and answer will be y by x. So you can easily come to know, before you start the problem, this is a homogeneous function of degree 2, therefore the derivative will be y by x. But however, I will not use this technique. I will continue this with a different method. What I am going to do is, to get this dy by dx in this format, another method I am teaching you. We can make y square as a subject. Now that also can be done in two ways. X square minus y square is sine a into x square plus y square. Bring all y square together, all x square together. X square into 1 minus sine a. Take y square all together, sine a plus 1. Coefficient of y square, sine a. Coefficient of minus y square, 1. So I can say from here, y square upon x square, y square upon x square is 1 minus sine a upon 1 plus sine a. I am going to derive this using another method, which is known as componendo dividendo method. Look at this, x square minus y square upon x square plus y square is sine a upon 1. If you apply componendo dividendo method, I can write x square minus y square plus x square plus y square, numerator plus denominator, upon x square minus y square minus x square plus y square, numerator minus denominator. Apply the same here, sine a plus 1 upon sine a minus 1. So what is this componendo dividendo method? Numerator and denominator is added in the numerator, and numerator and denominator is subtracted in the numerator. Whatever you do in the left, same thing is done on the right. So what happens here? I'll get the same condition here. I'll get 2x square upon minus 2y square is equal to 1 plus sin A divided by minus of 1 minus sin A. This minus will get cancelled. You can see the same answer coming up. Y square upon x square is 1 minus sin A upon 1 plus sin A. So you have option. Either use this method of making y square upon x square, or may use this method to get y square upon x square. So any problem of this kind comes, you will use this method and take y square upon x square. Now after this, there are two methods to proceed. One is differentiate as it is. Another is cross multiply and differentiate. Now depending on your answer, suppose I want the answer to be only y by x, you will directly differentiate. Right hand side will become 0 because a is a constant. Now when you differentiate this, you will end up in y by x. So now I'll show you that. So I can say x square into derivative of y square, 2y dy by dx, minus y square into derivative of x square, 2x, upon denominator square equal to 0. So this will get cross multiplied with 0. X square into 2y dy by dx minus y square into 2x equal to 0. So I can write x square 2y dy by dx is equal to y square 2x. So I will get dy by dx is equal to, cancelling all term, I'll get y by x. This is one way of doing the problem. So what I did, if I want the answer to be y by x, I don't want a to be present in my answer, then directly differentiate it. Suppose I want the answer to be like this. Show that y dy by dx is 1 minus sin A upon 1 plus sin A into x. So they can ask you the question in this manner, they can ask you the question in this manner. If you want the answer to be only y by x, you directly keep the constant on the left hand side and differentiate. A will not be present in the answer. Now I want a to be present in the answer. If I want a to be present in the answer, then I will change the steps over here. What I will do is, from this step onwards, I will make y square as a subject. So what is y square? 1 minus sin A upon 1 plus sin A into x square. If you differentiate this, 2y dy by dx equal to 1 minus sin A upon 1 plus sin A. This is a constant. Constant will remain as it is into derivative of x square. You will get 2x, and 2 and 2 got cancelled and you got your answer. So here again we notice two methods. One method is answer does not have a in it, sin A in it. So if you don't have sin A in it, keep all the constants. Sin A, I mean, if you don't have the constant present in it, make the constant on one side and then differentiate. If you want the constant to be present in the answer, cross multiply and differentiate, so that the constant will remain. When you define the derivative, what happens? The constant remains as it is and derivative of x square. Constant alone, what happens? Derivative of directly a constant becomes 0. So these are the two techniques that you need to apply in this type of problem. Another similar problem for one more practice. We have here log of x cube minus y cube upon x cube plus y cube to the base 10 is 2. One, you have to show that dy by dx is y by x. Another, we have to show dy by dx is minus 99 upon 101 x square divided by y square. So both are same kind as like last time I told you. If you want this answer, keep the constant alone on one side. If you want this answer, cross multiply and differentiate. So I'm going to show you both. First of all, I need to remove this log. To remove this log, take the base of log as the base of right hand side. So x cube minus y cube divided by x cube plus y cube is 10 square, which I can write as 100. So cross multiply it. X cube minus y cube is 100 into x cube plus y cube. These brackets are very necessary. Now bring all y cube to one side, x cube to other side. So suppose I take x cube to one side, x cube into 1, bring this 100 to left hand side, 100 is equal to, now y cube's coefficient is 100, when if this will come to left hand side 1 into y cube. I hope you understand that. X cube here, 100 x cube here. When you bring 100 x cube to the left hand side, it becomes minus 100. Your y cube here, when you bring it to the left hand side, it becomes 1 times y cube. So I can write x cube into minus 99 is 101 into y cube. Now, depending on my requirement, I'll arrange this. If I want this answer, I will write y cube divided by x cube is equal to minus 99 by 101. Now I'll differentiate this. When I differentiate this, this whole term will go away. So I will be getting like this answer. D by dx of y cube divided by x cube is d by dx of minus 99 upon 101. So u upon v method, and this becomes 0, you will come to this answer. So x cube into derivative of y cube 3y square dy by dx minus y cube into derivative of x cube 3x square divided by x cube the whole square equal to 0. Now this will get cross multiplied. So x cube into 3y square dy by dx minus 3y cube into x square equal to 0. I need to make dy by dx as subject. So I can write dy by dx is equal to 3y cube x square divided by 3x cube y square, and this becomes y by x. So the derivative will become y by x. So if you want the answer to get dy by dx as y by x, keep the constant on one side and differentiate, like the previous problem. If you want this answer to be present, what should I do? Just cross multiply and differentiate. Let's see that method also. So second question. So this is the first part of the question. Now second part of the question, only difference is y cube is equal to minus 99 upon 101 into x cube. Now if you differentiate with respect to x, your answer will contain this 99 upon 101 which is required. So 3y square dy by dx is equal to minus 99 upon 101 into 3x square. And you cancel off 3. So dy by dx is what exactly your answer? Minus 99 x square upon 101 y square. This is how you need to deal. There are plenty of questions like this in your textbook. I want you to solve all of them using this technique. So every problem with this kind happens. First of all, remember it's a homogeneous of degree of third degree homogeneous equation. You can see there are third degree homogeneous equation. Here you can see, here you can see, here you can see. Hence derivative got to be y by x. But if you want this particular answer, then you need to cross multiply and differentiate. So there are two kinds, no constant with the constant. No constant, keep constant alone on one side and differentiate. With the constant, cross multiply and differentiate. That's it. Another problem is x raised to m into y raised to n is x plus y raised to m plus n. You can see here also degree is same. Here also degree is same. X power is m plus n. This left hand side is also m plus n. So degree is m plus n. So it's a homogeneous equation of degree m plus n. So naturally prove that dy by dx is y by x. So any function, any homogeneous function of any degree you will always get the answer as y by x. So I will use the method what your board examination is expected to do. So to differentiate this, it is convenient to use log because there is a power and because there is a product. So I am taking log on both the side. Log of x raised to m into y raised to n is log of x plus y raised to m plus n. Although base and power are functions of x, then you have to take log. But being constant, it is not necessary to take log. Even without log, you can get the answer. But taking log, your derivative becomes much easier. So I'll spread the log. So m log x plus n log y is m plus n into log of x plus y. In my past experience, I've noticed that students forget this bracket for m plus n and the whole answer becomes something else. So be careful about this bracket. Whenever I say this, I always find that in the test, students would forget bracket again. So please take care of this part. Putting the brackets is a must. There is a danger here. So I am putting a danger mark here. What is the danger here? Putting the brackets. The brackets are danger. So please remember this. Otherwise you will make a mistake. Okay. Now let me continue. So differentiating with respect to x. Differentiate with respect to x. So your answer will be m into derivative of log x, n into derivative of log y, 1 by y dy by dx. So there is no need of bracket because they are multiplying. So there is no need of bracket. Is equal to m plus n derivative of log of x plus y. 1 upon x plus y into derivative of x plus y. So which we can write as m by x, n by y divided by dx, m plus n divided by x plus y into derivative of x 1 divided by dx. Another danger. Another danger. This bracket is another danger where students forget it and end up in wrong answer. Now how many terms with the divided by dx? I have 2 terms with the divided by dx, 1 here, 1 here. What are their coefficients? One coefficient is n upon y and coefficient of this is m plus n upon x plus y. So I can write n upon y minus m plus n divided by x plus y whole into divided by dx is equal to, what are the constant term? This multiplied with 1 minus this on the other side. These are the constant term. Now what to do? Take the LCM and simplify. Take the LCM and simplify. So what is the LCM? Y into x plus y. Now cross multiply. Nx plus ny minus my minus ny. Why minus again? Because of the negative sign here. Into dy by dx. Same procedure over here. X plus y into x. Now cross multiply. M into x, n into x, minus my, minus mx, minus my. Now let's see what are the terms getting cancelled. First and foremost, the denominator gets cancelled, x plus y. Second, you will notice that ny get cancelled, ny gets cancelled, here mx gets cancelled. Right? So what is left now? Nx minus my. What is left here? Nx minus my. So this numerator and this numerator also get cancelled. What is left with? Only this y by x. So I can just write that part here. So I will continue over here. Nx minus my divided by y into dy by dx is equal to nx minus my divided by x. Again, they both get cancelled. So finally what is left? Dy by dx is equal to y by x. So this is how you can derive the answer. So here one confusion will be there. Should we take log or not to take log? We take log because you can make the derivative easier. That's the reason to take log. So you can ask yourself, by taking log, what is the benefit, and not taking the log, what is the benefit? Once you understand that, it is very simple. And brackets are the dangerous here. The questions are regularly asked in the exam. So when they ask this, here one bracket and here this bracket. These two brackets are the most dangerous. So when you practice, you check whether these brackets are taken care or not. Otherwise, you will make